Now let's move on to the ozone layer depletion. As already I told you, depletion means holes. The main cause for the ozone layer depletion is chlorofluorocarbons. Chlorofluorocarbons we call as them CFCs. These are main responsible for depletion in the ozone layer. These chlorofluorocarbons produced in the environment, or you can prepare them, they are mainly prepared in the laboratories. When they were prepared for the first time, it's considered to be a boon to the industry, because the preparation of chlorofluorocarbons is very easy and it's very cheaper, and they are highly stable. Because of the stability, because of easy preparation, because of wide range of utility, chlorofluorocarbons when prepared first time, all over the world the scientists thought that it's a boon to the industry, but later it has become a curse to the environment. It's because the chlorofluorocarbons, when they attack the ozone layer, chlorine free radicals are produced. Each chlorine free radical produced can damage 1 lakh of ozone molecules. Like this, so many chlorine free radicals attacks so many lakhs of ozone molecules, which is causing holes in the ozone layer, depletion for the ozone layer, rupturing in the ozone layer. Ultimately, the thickness of ozone layer is decreasing day by day. We can see some holes in the Antarctica region, and because of that, UV radiations are falling. So mainly the chlorofluorocarbons are main responsible for depletion for the ozone layer. And the other reasons also we can notice, they can damage this ozone layer. Oxides of nitrogen, they also responsible for depletion in the ozone layer. That is the reason utility of supersonic jets by Russian in the country Russia, they banned the usage of jet planes, because the exhaust fumes of the jet planes, nitrogen oxides are produced. They are responsible for depletion for the ozone layer again. Like this, many sources are noticed, but the main cause for depletion is chlorofluorocarbons, and let's see the examples for them. CCl2F2, this is dichloro methane, systematic name, IPAC name. Commonly we call them as freons. We can call them as freons. These freons, preparation is easy, cheaper, highly stable. So they are used in refrigeration processes widely, and these chlorofluorocarbons, when enters into the stratosphere and attack the ozone molecules, let's see the sequence. Chlorofluorocarbons, ozone molecules in the stratosphere, and now these chlorofluorocarbons absorbs sunlight and produces chlorine free radical. Now each chlorine free radical is going to attack the 1 lakh ozone molecules nearly. So you can observe now O2 plus yellow free radical. Again this process will be continued, this reaction goes on, and again chlorine free radical are generated, ozone molecules have become into O2 molecules. Like this, the thickness in the ozone layer is decreased day by day. What are all consequences for depletion in ozone layer? As already discussed for you, once again let me tell you, directly ultraviolet radiations fall from the sunlight, enters into Earth's atmosphere and causes ozone layer, or causes eye cataracts and skin cancers, skin diseases and related health, skin related health problems may be noticed due to depletion in the ozone layer mainly. Then how do you eradicate it? How do you control the ozone layer depletion? We can control the ozone layer depletion by not producing, not utilizing this chlorofluorocarbons for refrigeration processes. Instead of using freons, though they are cheaper, we can go for non-chlorinated, non-chlorofluorocarbon containing refrigerants like liquid ammonia can be used. Like that, the other alternative refrigeration systems used in the air conditioning systems also, nowadays we are using substitutions for the chlorofluorocarbons in the name of R22, R23, like that we are using them. So in this process we can control the ozone layer depletion. And utility of supersonic jets, also been banned in some countries like Russia, because they are producing nitrogen oxides. These are causing chlorofluorocarbons. That is also we can control. By observing or by looking for alternative measures like this, we can overcome this problem. Now throughout the world, scientists banned the usage of chlorofluorocarbons for refrigeration purposes, but still already existing chlorine free radicals may damage ozone layer for another 50 years. So mainly we have to control the oxides of nitrogen release into atmosphere, chlorofluorocarbons into atmosphere, so that we can overcome this situation.